Hey guys, welcome to the 6.2 video about combining like terms. This time we're going to do a little more difficult examples where you have to combine things with x squareds. So the first question we're talking about here is perimeter, and you should know what that means. Perimeter basically means adding up all the sides. So make that little note to yourself there. And here we have a triangle and a rectangle. So what we're going to do is put all these three sides and kind of make them in one straight line. We're going to add up 3x plus 1, and then plus 3 plus x squared, and then plus 2x minus 2. So we're adding actually 6 different terms together. Here, if we just do a quick review of what we've learned before, terms are the things that are separated by adding and subtracting. So we have 1, 2, 3, 4, 5, 6 terms. So to add this together, we're going to use circles, triangles, and rectangles. So here we go. We have x terms that we're going to add together, and maybe we'll put circles around those. Remember, we put the sign in front of it. We include that in the shape. So the other x terms we have are just that 2x there. Other shapes we have are just the coefficients, or just the constant terms, the numbers. So we have plus 1, plus 3, and minus 2. Those are the same. And then just the x squared by itself is its own shape. It doesn't have a like term. And remember, there's a 1 in front of that there. So we actually have 3 different things we're going to add together. We're going to add, just keep that black x squared there in front. That's going to be our first one. After that, we'll add our blue circles together, the 3x and the 2x. Remember, with algebra tiles, that would be 3 green rectangles and 2 green rectangles. So that's plus 5x. And then the red boxes, we're just adding 1 plus 3 minus 2. 1 plus 3 is 4, and 4 minus 2 is positive 2. So our answer is this guy right here, x squared plus 5x plus 2. And we're going to write it in order of descending exponents. This is called descending order. Basically, we start with the highest exponent, then work our way down to just the x terms and then the number terms. So next example we have is we're going to find the area of this, the perimeter of this rectangle. Common mistake is people will forget to add up the sides that aren't labeled, but we know that they're the same as the opposite sides. So you could write this all out if you wanted to, or you could just kind of go ahead and put shapes around things now. So let's go ahead and put shapes around the numbers. So we have just 18, negative 14, 18, and negative 14. And it might be helpful to go off on a calculator and add that all up. We have, let's see if I can get that. There we go. If we add that up, we have 18 minus 14, or plus negative 14, plus 18, because it's positive, and then minus 14. That's a total of 8. So going back to this here, our total for those red shapes was, oh no, I forget what it was, 36 minus 28, was it 8 plus 8, I think? Check me on that. And then we have to add up our rest terms. Over here we have y terms, so we can put a triangle around those. We have negative 3y, 1y, negative 3y, and 1y. So putting those coefficients of 1 in front will help you out there. So what we have is we have negative 3 plus 1 plus negative 3 plus 1. When we add all those numbers up, you can use your calculator again if you like. Negative 3 plus 1 is negative 2. Plus negative 3 gives us negative 5. Plus 1 gives us negative 4. So our answer is negative 4y plus 8. Alright, so moving on down here. We have a couple different shapes we want to add together here in different terms. So what we have is, the difference here is we can't add together b squareds and b's. They're different terms. This would kind of be related to having, I guess that would be 4 big squares with algebra tiles, 5 big squares, and so on, and then 2 rectangles. And they're all positive. Okay, so when we add those together, you can't add together a big square with a rectangle. So let's go ahead and combine shapes here. For the b squareds, we could put any shape you want around it, 4b squared. And then anything else with b squareds get the same shape. So we have those two shapes added together. And then this one doesn't have an exponent of 2, it's just an exponent of 1, so it gets its own shape. So when we add together the blue shapes here, we have 4 plus 5, which is 9. And then just added together that 2b there, that's our final answer. We can't do anything else to combine those two. Example number 2. We have different shapes around these different terms. We have numbers and x squared terms. So if you look here, we can put a shape around -3. It's just the constant term. Other constant terms are anything without x's. And we're going to put a shape around the -7 there. And then we'll put different shapes around the other terms. So here we have x squared terms. We can add those together with any other x squared terms. So here we're going to combine basically 2 pairs of things. And I'm going to write the x squared terms first. So positive 2 minus 18 for the x squareds is -16. And then for the red circles here, we have -3 minus 7. And you can use your calculator for that too if you need to. It's -10. So once again, I wrote my answer in descending order with the higher exponents first and then the constant terms at the end. So that's our final answer, -16x squared minus 10. And example 3. Here we have, if we just look, we have x squareds, x's, and numbers. So in this one, we're going to have 3 different shapes. Now, an important note to put in for this one is, once again, we have a -1 in front of the x squared. That means there would be 1 red x tile. There would be 3 green x tiles. This color should have been green. It's a little darker there. And then 3 negative x squared tiles. Those are the big guys. 1, 2, 3. And then we'll have +3 of the white tiles. I'll just do that in yellow. So that's how we would do this with algebra tiles. We would be able to add together the red big squares and nothing else. So I'm going to erase that and we'll kind of do it without the tiles. Here we have these two same shapes, the big x squared tiles. So we have -1 minus 3. And that's -4. So we have -4 x squared. And then if you notice, we don't have any other of the same shapes. If we had to put a shape around this 3x, it would be maybe a square. And then this one is not the same, even though there's a 3. This one has an x. This one right here has an x, and this one doesn't. So this would have to be a different shape. So we can just write those in order. We'll put the 3x first, and then just the 3. So that's our final answer there. Only one thing can be combined there. And that happens quite a bit. Sometimes you might even have a question that you can't do anything to. Example 4. We have -a squared. We're going to put a circle around that guy. And why don't we squeeze a 1 in front of that too to remind us that there's -1. Next we have another -a squared. Our next shapes we have is a 5a and a 4a. So we have +5 and -4. We'll put the same shapes around those. And the last one doesn't have anything else to combine it with. So for the red a squareds, we have -1 plus -1. And that's -2. For the a terms, the boxes, we have +5 and -4. And when we add those together, we get 1. So we can say plus 1a. And then don't forget about that last 8 there, plus 8 at the end. So that would be our answer. If you wanted to, you could write it like this, with just plus a, plus 8. All right, now for the last 2 examples here on this page, we're going to do area and perimeter, both together. Remember that area for a rectangle means base times height, and perimeter means add up all the sides. So what I want you to do is do the perimeter. knowing that this is x minus 8 and this is 4. I want you to do perimeter on your own, and then push pause to check your, or push pause and then check your answer. Okay, for perimeter, we should have added together 4 plus x minus 8 plus 4 plus x minus 8. You could have done those in any order, but if you look at the shapes here, we have just the constant terms. 4, negative 8, 4, and negative 8. And then you have just the x's, 2 of those guys. And it's nice to be nice and neat about this. I kind of overlap some things. But for the red circles, we have 4 minus 8 plus 4 minus 8. If you do the math there, when all that works out, you get negative 8. And then for the boxes here, we have 1x and 1x, and that's 2x. So answer is 2x minus 8. For area, what we need to do is we need to do 4 times the whole thing, x minus 8. So this is the distributive property. What you want to do is take the 4 and distribute it to x and negative 8. So for area, we have 4 times x minus 4 times 8, which is 4x minus 32. So that's the area. Now the last part that I kind of want you to write down on the bottom of your page there, or on somewhere where you have room, are some examples of combining like terms where you have parentheses. And I didn't include those, which I should have. So let me get a new page here. I want you to write down 2 examples. First one we're going to do is 3 plus 2 times x squared plus 3x plus 1. And then the second one is going to be 6x minus 2 times b plus 4 minus 6. So the first one we're going to do, if you notice here, we try to do maybe 3 plus 2 first. That's probably what your first thought would be. But we don't want to add those together. Remember, we have to do parentheses first for order of operations. But there's nothing you can do inside these parentheses. You can't add any of those together. So we're actually going to do multiplication first. And multiplication means we're going to distribute just the 2. So go ahead and draw those arrows inside the parentheses. So what we're going to do is actually bring down this 3. We're not going to do anything with it yet. And then we're going to distribute 2. So 2 times x squared is 2x squared. 2 times positive 3x is positive 6x. And then 2 times 1 is positive 2. So what we're doing now is we're going to add together our like terms. So your first step is going to be distribute if necessary. And then the second step is going to be combine like terms. So what we have now is we got to combine our like terms. Here the only like terms we have are positive 3 and positive 2. So 3 plus 2 is 5, and we'll put that at the end. And then 2x squared and 6x, these two guys right here don't combine. They're different shapes. So we have 2x squared plus 6x, plus 5. Let me slide that over. And that's our answer. And the next one we're going to try, once again, we can't do 6x minus 2 first. We have to actually distribute. And what we're distributing is negative 2. And this is probably the hardest example on this notes right here. We're going to bring down our 6x first. And we're going to do negative 2 times b and negative 2 times b plus 4. So once again, negative 2 times b and then negative 2 times positive 4. So that's distributive property embedded in this. So negative 2 times b is negative 2b. Negative 2 times positive 4 is negative 8. And then we'll bring down this minus 6 also. So now we've done this first step of distributing. Now we got to combine our like terms. And I just made up this example. Actually, this is kind of a good one because there's an x and a b. These are not like terms, so we're not going to be able to do anything with those. But we do have minus 8 and minus 6. Those combine to negative 14. So our answer is 6x minus 2b minus 14. Thanks for listening, guys. Tomorrow when you get in here, you'll have a little pop quiz about these types of topics. We'll see you tomorrow.